In this video, I'm going to be working some examples of AP Precalculus free response question 4, and that's the one where we have to do all the algebra with the trig and exponential and inverse trig functions and log functions. It's the one that comes with the box of the directions where we have to simplify our answer. But the first one here I've got is, okay, I'm just going to kind of work this off to the side. Functions g and h are given here. Rewrite g as a single logarithm base 3 without negative exponents in any part of the expression, and then give us kind of a sample of what it should look like. All right, well, if we've got 2 logs plus 4 logs, that would be a total of 6 logs. So g of x is going to equal 6 times the log base 3 of x. And then single logarithm base 3 without negative exponents. Okay, well, we are going to need to kind of work on that 6, make that an exponent, so that's going to be log base 3 of x to the 6. It's one of our log properties that we absolutely must know for this exam. Okay, and that's going to be my answer to A1. Okay, and then A2, rewrite h of x as an expression in which secant x appears once and no other trig functions are involved. Okay, so I've got tangent, cosecant, cosine. I think in this type of situation where everything's multiplied together, I would be best off to just write everything in terms of sine and cosine. So tangent x is sine x over cosine x. And cosecant is 1 over sine. Okay, and then I've got a cosine in the denominator, so that's 1 over cosine x. Okay, and so I'm going to, cancel off the sines. And I'll see, okay, I've got 1 over cosine squared x. All right, I'm just going to say 1 over cosine squared x. They asked secant appearing once. Okay, well, I'm just going to say that's equal to secant squared x. And I guess that's just secant appearing once and no other trig functions involved. And in part B, they're going to bring out 2 new functions and ask me to solve 2 equations. All right, so first, j of x equals 4. So log base 2 of x plus log base 2 of x plus 6, that's going to equal 4. Okay, and what we're going to need to do if we want to solve a log equation is get it written as 1 log equals 1 number, so we can undo it with an exponential. So we need to get at that plus there using a log property. That's going to be multiplication on the inside, multiplication of the argument. So it's going to be x multiplied by x plus 6 inside the log base 2, and that's going to equal 4. Okay, I can distribute that x over the x plus 6, and I get x squared plus 6x, and that's still going to be equal to 4. Now I can take 2 to both sides power to resolve the log, and I'll have x squared plus 6x equaling 2 to the 4th power. And 2 to the 4 is 16. Just write that over there. Subtract 16 from both sides and get x squared plus 6x minus 16 equals 0. Now I think this is going to be factorable. Yeah, I can think of 2 numbers that multiply to negative 16 and add to positive 6. That would be 8 and negative 2. So x plus 8 times x minus 2 is going to equal 0. And if 2 things multiply together to equal 0, one of them has to equal 0, so either x, plus 8 is equal to 0, or maybe x minus 2 is equal to 0, and that would happen when x was negative 8 or positive 2. B2 is asking us to solve k of x equals 7, so something like 6 plus 2 sine squared x equals 7. Okay, so we're going to want to isolate the trig function. That would be subtracting 6 and dividing by 2. Okay, now if I'm going to solve for x, I need to get sine x on its own. So I need to think of sine squared x as sine of x squared. And then I'm going to take the square root of both sides, and I'll get sine x equals plus or minus the square root of a half. Okay, and I would prefer if you just knew that that was root 2 over 2. That was all the same number, 1 over the square root of 2, square root of a half, root 2 over 2, but root 2 over 2 is what we're going to need to be able to, probably recognize, so we can be like, oh, yeah, plus or minus root 2 over 2, we're going to be looking at the unit circle, all values in, 0 to pi. All right, so we're going to draw ourselves a unit circle. Thinking in the upper half, where is sine x root 2 over 2? Okay, well, root 2 over 2 is the pi's over 4, so that's going to be x equaling, what's that, pi over 4 and 3 pi over 4. That was B2. I'm realizing I'm going to put all my work down below. I'm not sure I'm going to have any room for part C. C wants me to find all input values in the domain of M that yield an output value of arc cosine of root 3 over 2. Okay, well, I think first we need to figure out what do they mean by arc cosine of root 3 over 2. Okay, remember, inverse cosine is it's a function in its own right, so it's going to give us one unique value. Okay, so I'm going to be interested in that part of the unit circle because that's where arc cosine takes its values from. Thinking about where is cosine equaling root 3 over 2? Well, root 3 over 2 is the last thing. It's almost all the way to 1, so that would be right there at pi over 6. Okay, so pi over 6 is what we have equaling m of x. Okay, yield an output value of root 3 over 2. Arc cosine of root 3 over 2. All right, so m of x equals pi over 6. So that's pi over 6 equaling negative 2/3 of arc sine 5 root 2x. These are, these are kind of weird ones. But if we just have faith, it ends up being all right. So I'm going to multiply both sides by 3 and divide both sides by negative 2. So that would be 3 pi over negative 12. And that's feeling like negative pi over 4 is equal to arc sine of 5 root 2x. Okay, now I'm going to have to get rid of the rest of the work here because I'm going to need some more space. And once I've got this equation right here, this is, I think where the trick is in this problem. I'm going to need to take this equation right there and take the sine of both sides. Okay, because if two things are equal, then their sine should be equal as well. So I'm going to be saying, that sine of negative pi over 4 equals sine of arc sine of 5 root 2x. Okay, so the sine of arc sine, then those are going to cancel each other out because they're inverse functions. Okay, sine of negative pi over 4, I'm going to draw a little trig diagram. I've got plenty of room. Negative pi over 4 is down here. Okay, and that's supposed to be a 45, 45, 90 triangle where the hypotenuse is 1, and both of these legs are going to be root 2 over 2. But since I'm in the fourth quadrant, that leg is going to be negative, and I'm going to see that sine is opposite over hypotenuse, negative root 2 over 2. And that's equaling 5 square root of 2 multiplied by x. Okay, so I'm getting closer. Definitely getting closer, yeah, and I don't need like a 2 pi in or anything here because I didn't go searching on the unit circle for all solutions to anything. I started with an arc cosine, but that's something different. And then in the blue stuff, I was going forward on the unit circle. I was taking the sine of negative pi over 4, and there's only one value of the sine of negative pi over 4, so there's going to be a unique solution to this equation. I'm going to divide both sides by square root of 2 first. Then I'm going to divide both sides by 5, and I'm going to have my answer, x equals negative 1 over 2 times 5. That's going to be negative 1 over 10. And there I've solved part C. Let's move on to another one. Okay, in this next number 4, I've got g and h, kind of more of the same. Got an exponential and a trig. Okay, rewrite g as an exponential of the form e to the ax plus b. Okay, Okay, well, I'm going to just start by combining, or maybe just one piece at a time. Maybe by working on that, power of a power. That's where we multiply the exponents. So e to the 10x multiplied by e to the x plus 3 divided by e to the 4. Okay, and then maybe I'll work on that multiplication right here next. That's where we're going to add the exponents. So 10x plus x plus 3, that would be 11x plus 3s. And then I'm still dividing by e to the 4. And when I'm dividing two things that have the same base and different exponents, that's where I subtract the exponents. So 11x plus 3 minus 4 would be e to the 11x minus 1. Okay, then, yeah, a and b are constants. There we go, we found it. Right, now for a2, we want to rewrite h of x as an expression that involves tangent x and no other trig functions. Okay, 1 minus secant squared x. That is one, it kind of, in my mind, I'm thinking that's one of the ones I'm supposed to know, but I don't, right? Because all I know is that sine squared theta plus cosine squared theta equals 1 for every theta. But, you know, secant squared and 1, I know there's a relationship between that and tangent squared, so I just don't remember exactly how it goes. But I do know this one, and I know that if I want to get a secant and a tangent, I'm going to need to divide both sides of this equation by cosine squared x. So I'm going to have sine squared x divided by cosine squared x is tangent squared theta, plus cosine squared theta divided by cosine squared theta is 1. And 1 over cosine squared theta is secant squared theta. Okay, now if I want 1 minus secant squared theta, I'm going to be subtracting a secant squared theta from both sides and a tangent squared theta from both sides. Okay, and that's what I'm going to be substituting on. I'm going to be using, okay, this identity right here on this piece of h. And so we'll be saying that this equals, okay, first, negative tangent squared theta. No, not theta x. Okay, multiplied by tangent x. Okay, so I'm going to have still that negative, but combining these, this will be 3 powers of tangent x. So I'll call that negative tangent cubed x. Right, and that's part A. For part B, we're going to solve j of x equals 3 for values of x in the domain of j. All right, so j equals 3. I'm going to work this off to this side and say, all right, well, first maybe I'll, work on that addition because I know, just like on the last problem, I'm going to need to multiply the arguments using that log property. So that's going to be log base 2 of x plus 5, x minus 2. And they want me to set that equal to 3. All right. So then I'm going to resolve the log by taking 2 to both sides power. So then I'm going to say x plus 5 times x minus 2 equals 2 to the 3 is 8. And then I'm going to probably need to expand that product there. I'm going to do FOIL x squared plus 5x minus 2x minus 10. And that will equal 8. I'm going to subtract 8 from both sides of the equation. Factor two numbers that multiplied at negative 18 and add to positive 3 would be, it's going to be 6 and 3, but it would need to be plus 6 and minus 3. Okay, so that's going to be x equaling negative 6 or x equaling 3. But because we solved a log equation, we could have possible extraneous solutions. And we need to go back in and check and make sure none of these are causing us to take the log of 0 or the log of a negative number. X equals negative 6 is causing that, so we're going to either erase that answer or strike through it so that the reader is like, okay, yeah, they do not want me to see that, or I'm not presenting that as an answer, that's an extraneous solution. That one was not in the domain of J, so that's not going to be one of the solutions we want to present. Okay, I think maybe the safest thing to do would be to erase it, but I don't think it really matters if we erase or cross out, as long as we are indicating that is not a solution that's in the domain of J. B2 wants us to solve k of x equals 0. Okay, so I'm going to just set this thing equal to 0. I'm going to notice that both of these terms have a sign x in them, so I'm going to factor out the sign. The sine x multiplied by 2 cosine x plus 1, and that will equal 0. Okay, if that's the case, then either sine x needs to equal 0, or maybe 2 cosine x plus 1 equals 0. Okay, that cosine x, if it equaled negative half, that equation would be true. And that's what I want to get it down to. Trig function equals numbers, so I can consult with a circle. Okay, once I do that, thinking about where is sine x equal to 0. Okay, well, the y coordinate on the unit circle is 0. That's going to be x equals 0, but we're only looking 0 to 2 pi, not including 2 pi, so I'm going to say I've got x equaling 0 and x equaling pi. And then as far as cosine x equaling negative half, remember negative half, not very far to the left on the unit circle, that'll be this spot and that spot. That's x equaling 2 pi over 3 and also x equaling 4 pi over 3. Those are the values of x on the interval that they wanted, so those are going to be our solutions to k of x equals 0. Now part C, oh yeah, I really like this one. This one's a little bit different. Find all values in the domain of m that yield an output value of negative 3. So that's looking for m of x equals negative 3. Okay, that's natural log of 2x squared minus 4 times the natural log of 2x equaling negative 3. And so I'm going to add 3 to both sides. And then I'm just going to do something right here. I'm just going to say, what if I just did that? That's my hint on how we're supposed to solve this one, right? We're just going to solve this one by factoring in natural log of 2x. Now, I'm going to, do a little something over here to the side, maybe to convince you that this is okay. I'm going to let u temporarily equal natural log of 2x. Then I'm going to have u squared minus 4u plus 3 equals 0. Okay, well, I know how to factor that. That's going to be u minus 3, u minus 1. That's equaling 0. Okay, and then that would happen if u is equal to 3 or u is equal to 1. Okay, but I know that u equals natural log of 2x. So whoops. Okay, a little ahead of myself. U equals 3, u equals 1, and then I guess I'm going to have to go up over here and say, all right, well, u equals the natural log of 2x. Okay, I'm going to get rid of the natural log by taking e to both sides power. Could even write it like that. So 2x equals e to the 3, or maybe 2x equals e to the 1. Then I'll solve for x by dividing both sides by 2. 1/2 of e to the 3, or 1/2 of e. And those are all values in the domain of m that yield an output value of negative 3. I guess, yeah, because this is solving a log equation, I should be checking my solutions for possible extraneous solutions, but neither of these values are negative, and it's just the natural log of 2 times x, so we're just kind of making sure that we're positive, and both of these solutions are positive, so we're ready to move on. Let's do another number 4. Okay, this next one I've got here, I think I've got 2 more of these. No, I've got 3 more of these. This is the treasure trove of examples of free response question 4. Okay, if you're needing the practice, you came to the right place. Okay, so the first one over here, solve g of x equals 1. Okay, so solve, say that's equal to 1. You know, it's really tempting to try to just multiply both sides by 8 to the 5. I think we should just use the exponent properties first. So in the numerator, I'm going to have 8 to the x plus 2x is 3x divided by 8 to the 5 equaling 1. And, you know, if you wanted to at this point, I think that would be a good thing to do. 8 to the 3x equals 8 to the 5. And then we could equate the 3x and 5, okay, because if 8 to the thing equals 8 to the other thing, then the things are going to have to equal. Okay, so 3x equals 5, x equals 5 divided by 3. Okay, then if we said h of x equals 2, okay, we're going to need to combine those logs that are added by multiplying their arguments. So that'll be log base 4 of x times 5 is 5x, and that's going to equal 2. I'll get rid of the log by taking 4 to both sides power, so 4 to the 2 is going to equal 4 to the log base 4 of 5x, which would be 5x. And then that's going to be 16 over here, and I'll solve for x by dividing both sides by 5, and I'll get x equals 16 divided by 5. Right, in part B, have functions j and k given over here. Rewrite j as a fraction involving powers of sine x and no other trig functions. Okay, well if that's the case, then we're going to want to do the thing where we're just turning everything into sine and cosine. So tangent squared x, sine squared x over cosine squared x. Okay, then multiplied by secant squared x. Well, secant is 1 over cosine, so this is going to be 1 over cosine squared x. And then, lastly, dividing by cosecant is like multiplying by sine. What are the instructions? Just in terms of sine x. Powers of sine x. Okay, I think I see what they're talking about. Yeah, so I'm gonna over here kind of just start combining stuff. That's gonna be 3 powers of sine x divided by cosine squared x twice. I'm gonna actually write it like that because if I want powers of sine x, I know that cosine squared x is related to sine squared x through the identity sine squared theta plus cosine squared theta equals 1 for every theta. So that means that cosine squared x is going to equal 1 minus sine squared x. So I'm going to go over here and say, right, this thing now is going to be equaling sine cubed x divided by 1 minus sine squared x squared. Okay, and nothing in the direction says we need to like expand binomials or anything like that. So I'm just going to leave it there. That's powers of sine x, right? And no other trig functions. That's a strange one, but we did hit the mark. Well, if we want to rewrite k of x involving cosine and nothing else, then we're going to have to deal with the sine of 2x. And we're going to need to remember our double angle formula. Now, you can get away with not remembering the double angle formula if you know the angle addition formula. I think it would be good for you to know that sine of 2x equals 2 sine x cosine x. Right, and then I could also say, but if I didn't know that, I could remind you, and this one you absolutely have to know for AP Pre-Cal, is that sine of a plus b is going to be sine a cosine b. And then because these are opposite trig functions, it'll be the same sign here that it was on the inside, so it'll be a plus, sine b cosine a. And if you knew that, then you could plug in a and b are both x, and then there you'd see 2 sine x cosine x. Okay, but we need to know that. Okay, one way or the other. So k of x is going to equal 2 sine x cosine x multiplied by sine x. And I think I kind of meant to write that substituted 2 sine x cosine x in blue, so I'm going to change that way. Okay, and then they want it to be involving cosine x and no other trig functions. So I'm going to need to do some work on this. I think I might write this as 2 sine squared x times cosine x. So the thing that's in my way is a sine squared x, and once again I'm going to use that Pythagorean identity that I know. I know that sine squared theta plus cosine squared theta equals 1 for every theta. Therefore, if I wanted to solve for sine squared theta, or sine squared x, that's going to be 1 minus cosine squared x. And then I would say, all right, well, now this original expression here is going to become equal to 2 times 1 minus cosine squared x and then another cosine x. Okay, as an expression involving cosine x and no other trig functions, that is an expression. It involves cosine and it does not involve any other trig functions, so I think that's going to be enough. Okay, now we're going to move on to part C, where we're going to have to use our angle addition formulas once again. Cosine of x plus pi over 3 minus sine of x plus pi over 6. So I'm going to bring in the sine addition formula. Oh, man. This one's going to, require us to access some knowledge. And then I'm going to write in the cosine addition formula as well. And in many ways, the cosine addition formula is the exact opposite. Okay, so that's going to be cosine A cosine B minus sine A sine B. And if you're wanting to remember why those are true, you should go back and look at my videos about that, about the angle addition formulas. It's, in the AP Pre-Cal playlist. But I'm not going to be getting into that here, or really even how to remember it. You just need to know it at this point, right before the exam. So cosine of A plus B and sine of A plus B, I've got those identities down. I'm going to need to rewrite m of x, because I want m of x to equal 3 halves. Okay, and so what's going to equal 3 halves is going to be cosine of x plus pi over 3. So that's going to be cosine x cosine pi over 3 minus sine x sine pi over 3. And then I've got minus sine of x plus pi over 6. Goodness. All right, so sine x cosine pi over 6. There's not even going to be enough room. Okay, just scoop that over some. Sine x cosine pi over 6 plus sine pi over 6 cosine x. It still wasn't enough. It's a very long expression. Alright, there we go. That's as far as I can go. Okay, so I'm going to need to be doing some trig work here. I'm going to need to be thinking about pi over 6. Okay, it's not going to be my best unit circle diagram ever, but okay, this is supposed to be my 30, 60, 90 triangle with pi over 6. Be a height of a half, a width of root 3 over 2, and a hypotenuse 1. And then for pi over 3, this one's going to be much better. A hypotenuse 1, long leg root 3 over 2, short leg a half. Alright, so cosine of pi over 3, that's root 3 over 2. Okay, so root 3 over 2 cosine x minus sine x sine pi over 3. Okay, so that's minus root 3 over 2 sine x minus, man, this one has got a lot going on here. I need cosine of pi over 6. Wait a second, I did something wrong here. Oh no, it's that first one. That should not have been a root 3 over 2. Cosine of pi over 3 is a half, yeah. That was erroneous. Let me make sure I did that one right. Sine of pi over 3, yeah. Okay. I was just looking at the diagram on the left. I should be looking at the diagram on the right. Okay, now on the inside, cosine of pi over 6, that one's root 3 over 2 times sine x, and then plus sine of pi over 6, which is a half, cosine x. And then, oh yeah, look at that. That's going to work out nicely for us. So it's equal to 3 halves. Yeah. All right. So 1/2 cosine x here. Subtract that one there. That's going to be 0. And then so I'm going to have negative root 3 over 2 sine x minus another root 3 over 2 sine x. That's going to be minus 2 root 3 over 2 sine x. That's just negative root 3 sine x. And now this is going to equal 3 divided by 2. And now I can divide both sides by the square root of 3. But you know what? When I do this, just to convince you of why this is going to work, instead of 3 halves, I'm going to still write it as a number of halves, I'm going to write the 3 as root 3 times root 3. Okay, so that you can see that when I'm dividing both sides by the square root of 3, I'm going to get root 3 over 2. And so sine x is going to equal negative root 3 over 2. And now that I've got it this far, I can get myself a unit circle, consult with it. That's just not looking like an x-axis. There we go. And say, all right, where is sine equaling negative root 3 over 2? Down here, which is going to be this one and that one, 4 pi over 3 and 5 pi over 3. Did it ask for everything in the domain of m? Yeah, so it'll be that and anything coterminal to that. So x equals 4 pi over 3 plus 2 pi n, where n is an integer, and x equals 5 pi over 3 plus 2 pi n, where n is an integer. All right. Next one, I've got 2 logs that I need to rewrite as a single natural logarithm. Okay, so more log properties. At this point, half an hour in, you get the drill. We're going to do some simplifying and rewriting and doing some solving as well. All right, so first I'm going to need to deal with this before I do the subtraction. So I'll have natural log of x minus 1 to the 6th power minus natural log of x plus 3. If I have subtraction of 2 logs, I can turn that into division of their arguments. And I think I'm just going to go for it in one line, because, yeah, it's natural log of an expression. That's going to be x minus 1 to the 6 divided by x plus 3. That's what we're taking the log of, and so I'm just going to leave it like that. All right, then part A2, rewrite h as an expression with sine once and no other trig functions. Okay, sine squared, tangent squared. Oh, that's interesting. I'm just gonna start in on it. I'm not seeing what's gonna happen here. Sine squared x over 1 multiplied by tangent squared is sine squared x divided by cosine squared x. Okay, which is, sine appears once. If it was cotangent or cosine squared tangent squared, that might make sense. I'm not loving this. This does not seem like it's going anywhere, because if I do cosine squared is 1 minus sine squared, that's not really very helpful in the denominator. Okay, so I'm going to go a different direction. I'm going to try to substitute on that tangent squared x and see what happens. Alright, so I'm going to go kind of off to the side and say I don't remember the identity for tangent squared. I'm not even being coy, I just don't know it. But I know how to get it by dividing both sides of this equation by cosine squared theta. Okay. Yeah, Yeah, I'm not really sure how this is going to help me, but maybe it's there. Okay, I'm going to keep going. Tangent squared theta is going to equal secant squared theta minus 1. So I've got sine squared x multiplied by secant squared x minus 1. Sine x appears once. If this was cosecant, that would make a lot of sense. So I'm going to have tangent squared minus sine squared. Then if I call that... Oh, well, that's what I had in the first place. What is going on here? Okay, yeah, after further investigation, this is not possible. So I'm going to get rid of... Actually, I'm probably not going to want to get rid of that. I'm going to change the problem to I think... I mean, if I'm going for sine appearing once and no other trig functions involved, I think what I want is for this to be, instead of sine squared, to be... No, this problem is just like, I don't know what they were going for on this one. I'm not even going to try. That one didn't work, but you've got many other examples of the simplify using trig identities that you could draw from if you were needing more of those. There's at least 5 or 6 examples of number 4 in this video. Okay, so j of x equals 3 to the 2/5. All right, so what they want you to do is take this thing and call that 3 to the x squared, and that is not what that is, even though they wrote it and making it really look like it wants to be that. When we have power of a power, we are multiplying the exponents, so that's 3 to the 2x times 3 to the 1 over 5, dividing by 3 to the negative 1. I don't know why you would divide by 3 to the negative 1. That's just going to become 3 to the 1 in the numerator. So it's 3 to the 2x, 3 to the 1/5 times 3 to the 1st. I'm just going to add all these exponents together. And so that's going to be 3 to the 2x plus 1 1/5 is going to be 6 over 5. Okay. Now, we want to know where j of x equals 3 to the 2/5. So if we want 3 to the 2x plus 6 over 5 to equal 3 to the 2/5, what we really want is for 2x plus 6 over 5 to equal 2 over 5. So I'm going to subtract 6 over 5 from both sides, and I'm going to get 2x equaling negative 4 over 5. I'll divide both sides in half, and I'll get x equals negative 2 over 5. And that was much better. Okay, this next one wants us to solve k of x equals pi over 12. Okay, well, I'm going to multiply both sides by 6 and get 6 pi over 12, so that's arc sine of pi x minus 2 equaling 6 pi over 12 is pi over 2. I'm going to take the sine of both sides, and I'll get pi x minus 2 equals sine of pi over 2. Okay, I'm going to consult with the unit circle to evaluate that. Pi over 2 is up here, sine is the y-coordinate, that's going to equal 1. Okay, so I'm going to add 2 to both sides to get pi x equaling 2 plus 1 is 3, and x is going to equal 3 divided by pi. All right, and that's a unique solution because there's only one value of sine of pi over 2. So that one was interesting. And then part C has got a log equation. We want to just know the zeros of this thing. It's going to be really tempting to take the two logs and set them equal to each other, but that half is in the way, so we're going to have to deal with that no matter what. So I think we might as well just call m of x equals 0. Actually get going on that log, so it's going to be log base 7 of x minus log base 7 of that thing to the half power, so the half power is the square root, 2x plus 8 on the inside. Okay, then that's going to be combining two logs with subtraction. That could be the same as combining them with division inside the argument. So it's going to be x divided by square root of 2x plus 8. And that's going to equal 0. I'm going to take 7 to both sides power. Okay, so 7 to the log base 7 of that thing is just going to be that thing. Square root of 2x plus 8. And that's going to equal 7 to the 0, which is 1. And then I'll multiply both sides by the square root, and I'll have, right, let's go back up here, x equaling square root of 2x plus 8. I will need to square both sides, and then that means I need to be careful at the end and check my result for extraneous solutions. X squared equals 2x plus 8. And then I'll set this thing equal to 0. Thinking about factors of 8, like 4 and 2, yeah, those could add up to -2, so that would be x minus 4 multiplied by x plus 2 equaling 0. That's x equaling 4 or possibly -2, but we definitely want to check that, yeah, -2 is not going to work because we can't plug it back into that part of the original expression. So I'm going to either strike through that or erase it, or make sure to throw a box around just this guy to indicate to the reader that that is my only answer. That's the only value in the domain of M that yields an output value of 0. All right, now we've got one more of these examples of free response question 4, and this one looks interesting. Secant, we haven't had any of that. Solve g of x equals -4. Okay, so if this is going to equal -4, I'm going to divide both sides by 2, and I'm going to get secant of x minus pi over 3 equals -4 over 2 equals -2. Now, I've got it down to trig function equals number, but me personally, I'm bad at solving equations that involve secant, cosecant, cotangent, even tangent, so I should probably write this in terms of cosine. If we know the secant, we know the cosine, right, because they're reciprocals. So if the secant is -2, then the cosine is going to equal -half, and this is something I feel much more confident using a circle to solve. Okay, so cosine is the x, okay, -half is not very far over to the left, so that would be 2 pi over 3 and 4 pi over 3. So on the interval 0 to 2 pi, okay, so x minus pi over 3 might equal 2 pi over 3. And then x minus pi over 3 equals 4 pi over 3. Now, if one of these ended up going outside the interval 0 to 2 pi, which it's not, I would definitely check like the negative values that made this true. Like, I guess that's -2 pi over 3 also works. Different name for 4 pi over 3, but that's not going to be necessary in this case. So we're going to add pi over 3 to both sides of both equations, and we're going to say, all right, it could be 3 pi over 3 or possibly 5 pi over 3. I like that one. That was a good question. Then A2 is saying h of x equals 1. Okay, so just like the other ones, I'm going to probably, need to, first things first, use a log property. So that means log base 3 of divide the arguments if we're subtracting. So that's x minus 2 divided by x plus 1, and that's going to equal 1. I'm going to resolve the log by taking 3 to both sides power. So I'd get x minus 2 over x plus 1 equals 3 to the first. Then I will, you could think about it as cross multiplying or just multiplying both sides by x plus 1. Okay, so that's x minus 2 equaling 3x plus 3. I might subtract an x from both sides, maybe subtract 3 from both sides as well, divide by 2, and get x equals -5 halves. Right, and looking at h, -5 halves, wait a minute, plus 2, that's a negative number. I feel like I've possibly made an error here. Yes, I have made an error. I made a copy error at the beginning. That's an x plus 2, so That's an x plus 2, 2 minus 3, that's going to be, okay, yeah, that's going to be -1, and that's going to fix it for me, yeah, so -1 divided by 2, that is still a negative number, which is concerning, but look, we're adding 2, adding 1, yeah, that's, okay, I'm going to be able to do that. Okay, so x equals -1/2 is the solution we were looking for there. Okay, part B has got functions j and k, and we're going to write j is a product involving secant and cosecant. Okay, that's interesting. Okay, tangent plus cotangent. What we should probably do here is write these in terms of sine and cosine, and just who knows what to do from there. But tangent plus cotangent is going to be, I'm working B1 here. Cotangent is cosine over sine. So I probably need to get a common denominator. So sine x cosine x over... Wait, no, I did that wrong. What do I need? I need to, probably should have said it out loud. What do I need on the, to get the common denominator for that term on the left? I need a sine x, so I can have a sine x and a cosine x. So if I multiply the first fraction by sine x on top and bottom, I'd get sine squared x. Okay, yeah, I see where we're going here. Divided by cosine x sine x. And then I'll add that to, okay, what am I missing on the second term of my expression? Okay, in the denominator, I'm missing a cosine x, so I'm going to multiply top and bottom by cosine x and get this. I've got a common denominator, so I can add them together, keep the same denominator, because, 1/5 plus 3/5 is 4/5. And then I have sine squared x plus cosine squared x, which you definitely need to know is equal to 1. Okay, so I've got a 1 divided by cosine and sine. And this is kind of, I don't love this because it doesn't seem like they really grade the work on this problem. Or at least there's no indication that they are grading the work from the scoring notes. And the answer is, isn't it just secant times cosecant? Yeah, that's, a product involving secant and cosecant. Anybody who knows what the word product means could probably just guess the answer and be right. So that one's a little weird, but that's how you do it. And k, single natural log, no negative exponents anywhere. Okay. Right, well, I'm just going to start with that 3 natural log x and make that natural log of x cubed. That 1/2, I'm going to make that a square root, natural log of the square root of x plus 4, because that 1/2 can be written as a power of the argument, and the 1/2 power is the square root. So plus natural log of 2x minus 1. Okay, and so, right, well, I'll just start with the subtraction. That's going to become division on the inside. So x to the 3 divided by square root of x plus 4 plus natural log of 2x minus 1. And if I want to combine this into a single natural log, I'm going to be multiplying the arguments. So x to the 3rd divided by square root x plus 4 times 2x minus 1. It didn't say we had to distribute out all products or anything in the direction, so I think this is going to be a safe place for us to stop. It said no negative exponents, right? Okay, I don't have any negative exponents there. Log of an expression, that is definitely natural log of an expression. That's definitely what we got. All right, now the last one here is all input values that yield an output value of 1/2. Now this one's interesting. Sine x plus cosine x squared. We must need to use a trig identity because we don't, if I just took the square root of both sides, that's not going to be all that helpful. Sine x plus cosine x equals root 2 over 2 or negative root 2 over 2. It's temptingly close to stuff we know from the unit circle, but it doesn't seem quite right. So what I'm going to do is I'm going to actually square, write out m of x. So if I take sine x plus cosine x and I square it, we need to multiply it out like this. And I'll have a sine x times sine x is sine squared x. Outside, maybe I'll do last next. Cosine x times cosine x is cosine squared x. I definitely want those together because maybe you see where I'm going to be going with this. And then plus cosine x sine x plus sine x cosine x. That's going to be 2 sine x cosine x. Oh, wow. This one's kind of intense. Okay, we need to know that sine squared x plus cosine squared x is 1. That's for sure. But then, I guess we do also need to know our double angle formula. Right, that this expression right here, this is equal to sine of 2x. So I'm going to have 1 plus the sine of 2x equaling 1/2. I'm going to subtract the 1 from, let me just get more paper. Subtract 1 from both sides and get sine of 2x equals 1/2 minus 1 is -1/2. Now that I've got it down to trig function equals number, I can consult with a circle and draw one out here. Thinking, all right, where is sine -1/2? So that's not very far down. That's going to be these two spots. So that means that 2x is going to equal 7 pi over 6. It said everything in the domain of m. Okay, so there's no real restrictions on that, so we want everything coterminal to that as well. And 2x equals 11 pi over 6. If you wanted to call that negative pi over 6, that would be just as good. And then I will get my actual solutions by dividing both sides by 2. 11 pi divided by 12 plus 1 pi n, where n is an integer. All right, now, okay, that's my solutions, and yeah, that's the last problem, so that's going to be all for this video. That was a pretty comprehensive run-through of examples of free response question 4, so I hope it was helpful. Thanks for watching.